In this video, we're going to look at using the binomial distribution to calculate probabilities and the expected value of playing a three bucket lottery. There are 3 buckets of ping pong balls in this example. Each bucket contains 20 ping pong balls, and the balls are all labeled 1 to 20. Gamblers must pick all 3 numbers correctly to win the $4,000 jackpot. Gamblers win nothing if they get one or more of the numbers incorrect. Each lottery ticket costs $3. The binomial distribution can be used to calculate the probability of getting 0, 1, 2, and 3 of the lottery numbers correct. In Excel, the command for doing this is equal binom.dist. Since the gambler can pick 0, 1, 2, or 3 correct lottery numbers, there are 0, 1, 2, or 3 successes. Since there are 3 buckets of ping pong balls, there are 3 trials. Using 2 decimal places, the probability of getting a number correct from a given bucket is, well, since each bucket contains 20 ping pong balls, and if you pick the winner from a given bucket, the probability of you doing that in a random process is 1 divided by 20, or 0.05. That's the probability of success. So we have, you can have 0 successes, which means you got none of the balls correctly picked. You can have 1 success. 1 of the ping pong balls is correct and 2 are incorrect. You can have 2 correct ping pong balls and 1 incorrect ping pong ball. And you can have all 3 ping pong balls as successes. So we have 0, 1, 2, or 3 successes. We have 3 trials, and the probability of success is 0.05 since there's 20 ping pong balls in each bucket. The final input to the Excel command, binom.dist, is true or false. And we're going to say, you can either do false or you can do true, but we're going to do false because false says don't use the cumulative binomial distribution, right? So we're going to say false there. Okay, so we're going to use this command here. We're going to copy this into Excel. And I'm going to place it here. I'm going to hit 1. I'm going to hit enter. Sorry. So this is X, number of successes, and we can have 0, 1, 2, 3 successes, right? Now, the command I copied in from my Open Math had the 0 here in red. And the reason why it's in red is because it's going to vary. So these are all parameters that don't vary, but this does vary. So instead of using 0 there, I'm going to click on the cell that has 0, and I get the same number. This is the probability of getting 0 balls correct. That's the probability of getting 1 of the balls correct. That's the probability of getting 2 of the balls correct. And this is the probability of getting all 3 balls correct. And how many decimal places do we need? We need, let's see, we need 6 decimal places right there. So we have 6 decimal place accuracy right there. So we're going to copy this into here. Copy this into here. And f of x, you can think of f of x as the frequency or relative frequency of 0 ping pong balls correct, 1 ping pong ball correct, or 2 ping pong balls correct. Or you can think of it as a probability. So these right here are probabilities, and f is our probability density function. Okay, now we're going to calculate the mean. So this is our probability, or f of x. And to calculate the mean, we need to take each of these values, 0, 1, 2, 3, and multiply them by their corresponding probability. So the first one's pretty easy, and we do that for all 4 outcomes. And then the expected value is just the sum. So we expect to get 0.15. We don't expect to get 1 ping pong ball correct. We don't expect 0 ping pong balls correct. We don't expect to get 2 ping pong balls correct. We don't expect to get 3 ping pong balls correct. We expect to get 0.15 ping pong balls correct, which is really close to 0. Our expected value is that. This one was 0. This is just times 1. Then we have times 2. Then we have the probability times 3. Let's go see. Let's go ahead and hit enter and see how we're doing. We'll hit OK. And we got everything perfect so far. Now, the probability of getting all 3 lottery numbers correct equals what? Well, that number right there. If you get all 3 lottery numbers correct, you net what? What do you net? How much did it cost you to play the game? It cost you $3 to play the game, right? On net, you're going to get 4,000 minus 3, right? So if you get all 3 ping pong balls correct, you win $4,000, but you got to remember, you got to pay $3. So if you get all 3 ping pong balls correct, you net $3,997. What about the probability of getting 2 or fewer lottery numbers correct? 2 or fewer means we have to add that to that to that. So I can do that in Excel. So I'm going to move this over here. So the probability of getting 2 or fewer ping pong balls correct is pretty close to 1. If you don't get all 3 lottery numbers correct, what do you net? Well, you net a -3, right? Because you win 0. You win $0. 0 minus 3, the amount you had to pay to play, is -3. So here you win 0, and you had to pay $3 to play. And then the probability of winning, getting all 3 balls correct, is that. So this is if you win, and this is if you lose. Okay, so to calculate the expected winnings, what you do is you take how much you'll win and its probability plus how much you get if you lose times its probability. And so you're going to lose $2.50 on every $3 you bet over the long run. Based on this, should the state enact this lottery? Well, I'd say yes. Because on a $3 bet, the state wins $2.50. It takes $2.50 of it. So let's say yes. We got everything correct.